fellow mathematicians, and welcome back to the art of integration. We're going to take a look at an integral here where we'll solve it using a method or technique that I call advanced substitution. Now, before we go through that, let's go back to regular or normal substitution, like you would have learned in your calculus courses. I'm going to use the variable t instead of u. Some problems we're going to look at, we want to use u for integration by parts. So let's, for substitutions, think of using t instead. Now back with a normal substitution, you would have chosen u as some function of x, and now we choose here t as some function of x, calculate your differentials, and go from there. Now what's called an advanced or inverse substitution, it's like what you learned in your Calc 2 course with trig substitution. You don't choose a function for u in terms of x, but rather you choose x as a function of some other variable. So if we reword this, substitution is choosing t as a function of x. Advanced substitution, we're going to choose x as a function of t. And how we choose our substitution here in this setting of advanced substitution is we want to kind of look at our integral and figure out what function of t might cancel or simplify the function that we're integrating there. So if we go ahead and take a look at this, it seems like if we try x as t squared, notice if you plug that in, square roots of t squareds will cancel out. So this seems promising. So if we calculate differentials here, we'll get 2t dt equals dx. And now we can convert everything here, the function as well as the differential dx, to our new variable t. So let's plug everything in. So here we're going to get square root of t squared. Same thing in the denominator, but now 1 plus the square root of 1 plus t squared. And we have to convert dx from our inverse or advanced substitution, 2t dt. All right, and notice here from our choice of g of t, t squared here, that's going to cancel out the square roots. And if we simplify this, we get the integral. Notice in the numerator, that becomes t. We have 2t here. We can write this as 2t squared. And then in the denominator, square root of t squared cancels to t. Let me just switch the order and write that as t plus 1. All right, and now we're left integrating this, and that looks much simpler because there's no more radicals or square roots. Now, you could try to think back to your Calc 2 course where you learned about integrating rational functions. This one is improper. The degree of the numerator is greater than that of the denominator. One trick you can use for that is long division. So let's go ahead and perform polynomial long division, and we'll be very easily able to integrate it after that. So let's set this up. We're going to be dividing by t plus 1 into 2t squared, but I'm going to write all the missing powers from there going down. So 0t plus 0. So let's write that as 2t squared plus 0t plus 0. And the way we go through long division is take your leading terms and divide them. So first we're going to do 2t squared divided by the leading term t. And that simplifies to 2t. All right, we take 2t, multiply it back and subtract. And what you should find is that the leading terms always cancel. So we get 2t times t. That'll be 2t squared plus 2t. And if you subtract, the 2t squareds cancel. And just be careful with your signs. You have 0t minus 2t. So we get negative 2t. And if you want, you can carry that 0 down. All right, repeat this. Now divide your new leading terms. Negative 2t divided by t. That's going to come out to negative 2. So we go ahead and put that up there. And we're going to multiply back and subtract. All right, and again, the leading terms should cancel. So multiply that back, we'll get minus 2t. And then multiplying to positive 1, we'll get minus 2. All right, and again here, notice when you subtract, the leading terms do cancel. Negative 2t minus a negative, that's really plus. I always like to write my work for long division with the minus there as a reminder to actually subtract. So your leading terms, the 2t's cancel out, but you're left with now negative 2, so that's going to be positive 2. All right, and what you get at the end here, that is your remainder. So the work from long division, what we have arrived at is that 2t squared divided by t plus 1. We have the whole part, 2t, minus 2, and then we have our remainder, which is 2 divided by t plus 1. All right, and notice in terms of t, that is the function that we're left with integrating with respect to t. All these terms are very easy to integrate. So let's go ahead and plug that in right here. We just rewrote our function basically by going through long division. So we get 2t minus 2 plus 2 divided by t plus 1. And now we can integrate very easily. Apply the power rule. 2t will integrate to t squared. Negative 2 will integrate to negative 2 times t. So minus 2t. And this 2 divided by t plus 1, that just integrates to 2 times natural log of t plus 1. And our last step, like with normal substitution, remember you back substitute all your u's in terms of x. Here, we're just going to back substitute our substitution for t's in terms of x. So we have that right from the beginning. T squared equal to x. And you can see here we're going to need t by itself. So take a square root of that and we get t equals square root of x. So if we go ahead and convert term by term, t squared just converts to x. We have minus 2t, but t becomes square root of x, so that's minus 2 square root of x. And then this natural log term, we're going to get natural log of t square root of x plus 1. But let me just switch the order there of the t and 1 and write this as natural log of 1 plus square root of x. And there we have it. We get our antiderivative using advanced or inverse substitution. Now, this is not the only way to evaluate this integral. You can go through it using basic or normal regular use substitution, but the work is a little bit different. This problem on using an advanced substitution, choosing x as t squared, this is one of the simplest problems that'll set us up for more complicated advanced substitutions. So check those out in the future. All right, I hope you enjoyed the video. If you figured out other ways to integrate this, let me know. Leave comments down below, and I'll respond with maybe some follow-up videos on that. Hope you enjoyed the video. If you did, support the channel, like and subscribe.